Welcome everyone. Good morning, good afternoon, good evening. Welcome to re:Invent. My name is Laura Caicedo. I am a solutions architect in the UK Ireland team. And today I'm here to speak about VPC endpoints and PrivateLink. As customers start growing their architectures on AWS, then the number of endpoints start growing as well. And one very common question is, should I have all my endpoints in a centralized account, or should I deploy each endpoint in each VPC? Well, I'm going to try to answer that question today from the security, from the cost, and from the operations perspective. So be with me. The agenda for today is really simple. We will do a quick recap about AWS PrivateLink, what it is, how it works, and what are some of the benefits of using it. Then we will spend the majority of the time talking about PrivateLink at a scale. When customers have more than hundreds or thousands of VPCs, then what are the different architectures to deploy these endpoints? As I say, we will be looking this from the cost management and security perspectives. Last, we'll go into some use cases scenarios, some common customer scenarios, and we will define between both architectures, centralized or decentralized. So let's get started with a recap. But before jumping into what is PrivateLink and how it works, I want to set the mood for this. PrivateLink is becoming really relevant, and it's becoming the de facto way of consuming services on AWS. Right now, there are more than 95 services that are available through PrivateLink, and then every day more and more partners are adding their ISVs or their SaaS providers and making that software available using PrivateLink. So that's why from now on you should start considering in the long term, and if you have hundreds or thousands of VPC, what are the best way to deploy this type of architectures. So when we talk about VPC endpoints, then there are three common VPC endpoints. The first one is the gateway endpoints. It's commonly used for S3 or DynamoDB. Then we have the gateway load balancer endpoint as well. And then we have the interface endpoints or PrivateLink. I want to say that most of the presentation will be focusing on interface endpoint, or what is called PrivateLink. So what is PrivateLink? PrivateLink allows you to access to an AWS service or to a service hosted by a third party in the marketplace using AWS private network. What it means? It means that now every time that you're going to consume an AWS service, let's put example as an API gateway or Kinesis, you instead of reaching the public endpoint and going through the internet, you're going to reach the service using PrivateLink and using AWS private network. One of the main advantages of this is that it gives you an extra layer of security, because all the communication can only be initiated from the consumer side. It means that if I want to consume API gateway, or if I want to consume a service hosted by a third party and consume through PrivateLink in the marketplace, then I am the only one that can initiate that communication. Once the communication is established, then the software or the service will be able to respond or to reply to my request. But that adds an extra layer of security. How it works? Then the first, on the top, we have a provider VPC. This provider VPC could be a service provided by a third party, could be a microservice hosted by you in a different VPC or a different account. And the idea behind PrivateLink is that on the left, you have the consumer. And the consumer is going to reach that service using an endpoint. Behind the scenes, that endpoint is deploying an elastic network interface. It also means that now, since it's an elastic network interface within your VPC, it will have a private IP within your CIDR range. So now your application, your consumer, will think that it's consuming that provider service as if it were running within your own VPC. The second type of service is an AWS service. I already mentioned that. You can consume API Gateway, or you can consume a CloudWatch API, or 94 more services using PrivateLink. And the third one is when you decide to consume a service from the marketplace. So what are some of the benefits of using this type of architecture? The first one is a highly scalable endpoint. This endpoint can scale up to 4 gigs per second. So it will allow you to have a huge bandwidth in order to consume the different services running on AWS or hosted by a third party. The second benefit, it helps you to have a simplified network architecture. You don't have to be thinking about VPC peering, configuring route tables, internet gateway, none of that. Now you can just start consuming network or services in a different network, even if there are overlapping CIDRs. The third advantage that I've been talking a lot is security. Remember that the communication can only be initiated by the consumer. And also remember that I mentioned that you have an elastic network interface. Because you have an elastic network interface, you can also configure a security group. You can shape traffic, you can filter the traffic depending on your rules, and also each endpoint has an endpoint policy, where you can also filter what type of requests are allowed or are denied. Another benefit is the multi-account, because now you can just deploy services in a different accounts and start consuming it easier and faster. And one of the last benefits is marketplace integration. This allows agility. Now, if you want to consume that service running or exposed in the marketplace, then you will be able to do it in a faster way. The last benefit is enabling hybrid cloud. This is a perfect use case when you have applications on-prem that need to access to that service running in a different VPC or running behind an API gateway. Then you can do this through PrivateLink. So now that we did a quick recap about PrivateLink, some of its benefits, how it works, I want to go and spend more time talking about decentralized and centralized endpoint architecture. Remember, this is an architecture when you have more than 100 or thousands VPC. The options are really simple. There are two different options. The first one is a decentralized type of architecture. So on the left, we have endpoints running in each VPC. For the sake of the diagram, the endpoint is the purple circle, and it's running in the yellow VPC. And the idea is that every time that you need to consume a service, then you will deploy a separate endpoint in each one of the VPCs. Then on the right, we have the centralized architecture. In here, rather than deploying each endpoint in each VPC, now you will have a centralized account where you will deploy all your different endpoints. And you can make them available through a transit gateway. But be with me. I'm going to explain in more detail what each of these architecture means. In a decentralized endpoint architecture, on the left, you have your consumer, your application that needs to connect to two different services, API Gateway and Kinesis. You deploy an endpoint in each availability zone. Because there are two services, then you end up with two endpoints. Following our best practices, we always recommend 3 availability zones. So my whole presentation will be deploying endpoints in 3 availability zones. But for the sake of the diagram and for the sake of my slides, I am going to simplify the draw like this. I'm going to only draw one availability zone or a single one, but please keep in mind that behind the scenes, I'm always referring to 3 availability zones. So in the decentralized type of architecture, you have your endpoint, and now you deploy a new account, and that account also needs to consume those services, Kinesis and API Gateway. Very simple. You deploy an endpoint in that VPC, and now the connection from the VPC to the service or to the AWS cloud will be directly, remember, using our private network. The more consumers, the more VPCs, the more accounts that you start to deploy, then the more endpoints that you will also need to deploy. If you want to shape traffic, in this case, then you can do it through an endpoint policy. This endpoint policy, you can decide which services behind, in this case, that API gateway, your consumers are able to deploy. This is an IAM policy, very simple. If now you start growing your architecture and you decide to deploy an extra microservices running in a different VPC, and some of your applications need to consume it, then more endpoints will be deployed in each VPC. Okay? So this is how the decentralized architecture looks like. Endpoints per each VPC, endpoints per each service that the consumers need to connect to. Now, let's jump and talk about the centralized endpoint architecture. In a centralized endpoint architecture, there are three main considerations. The first one is following the multi-account best practices. Then it's a good idea to have a shared service VPC or shared service account where you will deploy all the AWS service endpoints, all the third-party service endpoints that you consume through our marketplace, or any internal services exposed using PrivateLink. Once you have your account set up, and this account is connected to the services, like in this case, the dotted line means the AWS private network consuming on the left AWS services, and on the right, an internal service powered by PrivateLink. Now, the second main consideration is a transit gateway. A transit gateway will allow you to connect from the consumer to the shared service account. You might be thinking, can I do this using VPC peering? The answer is yes, you could do this using VPC peering. But please remember that we're talking about hundreds or thousands of VPC. Probably a transit gateway is already in place, and probably a transit gateway is a good idea. How this is going to work is really simple. You have the provider, the red envelope, and the blue one on the top, and the traffic is going to go through the transit gateway, through the shared services account, and then using AWS private network to the service itself. Okay? Also, if you have services running on-prem, you can connect to them using the transit gateway through VPN or the Reconnect, and you can make that service available as well. The third consideration is the DNS. So for the DNS, first thing, you need to disable the private hosted zone at the endpoint level. So you go to the endpoint, you configure private DNS off, and then let's say that you have an API gateway that is exposing an API, and you have a Lambda on the top that needs to consume that API. So already you disable the private hosted zone at the endpoint level. The next thing that you need to configure is a private hosted zone using Route 53. In this private hosted zone, you will resolve all the calls to the API gateway to the VPC endpoint on this alias. You will share this private hosted zone with the consumer and with the provider itself, and now the communication will be able to happen between the Lambda on the top and the API gateway on the bottom left. So far we have talked about what a centralized architecture looks like, how a decentralized architecture looks like. Now, let's start comparing each one of them from the cost perspective. On the left, we have the decentralized architecture. And the decentralized architecture is costed very simple. It's per endpoint. Each endpoint is something around $7.30 a month, assuming that you're consuming the endpoint 730 hours per month, plus the data processed per endpoint. On the decentralized architecture, you're paying per endpoint per VPC. Remember that you will be deploying each endpoint in each VPC. On the other side, we have the centralized model. In the centralized one, you will pay again per endpoint, but now rather than having each endpoint in each VPC, you will have a centralized account with all the endpoints running there, right? So you will pay only once per the endpoint. But you have to add the transit gateway prices. The transit gateway prices are transit gateway attachment price plus data process, right? These are prices for October 2020, and just keep in mind that this is today current pricing based in Virginia. Now let's jump into a little bit of more detailed scenarios from the cost perspective. Let's assume that you have 50 VPCs, 50 gigs of traffic, and 5 services. In this case, the centralized architecture comes with a lower price than the decentralized one. If now, instead of 50 VPCs, we increase it to 500 VPCs, then still the centralized is a better, it has a better price from the cost perspective. But if we change the traffic and now instead of 50 gigs, we have 500 gigs, then the decentralized has a more cost-effective price. And it makes sense if you think that the transit gateway is adding 2 cents per data process. And now we're processing a lot of data. So it makes sense that the decentralized one has lower price. If we increase the number of services, then still the centralized one is better from the price perspective. However, we're talking about hundreds of VPCs. And if you have 50 VPCs or if you have 500 VPCs, it's really likely that you already have a transit gateway in place. So I decided to show the prices of the centralized minus the transit gateway, including the attachment cost. That way you can have an apples to apples comparison between the centralized and the decentralized type of architecture. Some conclusions is, well, the centralized is generally more cost effective for higher number of endpoints. For higher traffic, the decentralized approach is a little bit more cost effective. If you have low number of endpoints and low number of VPCs, then price between the centralized and the decentralized can vary. And please do your own math. Use our AWS calculator. Every scenario is totally different and it's complicated. So please do your own math, work with your own essay to help you through this process. But now, cost is not only the consideration when choosing one over the other. We need to also consider security and management. And let's start with this decentralized model on the left, from the security and management. One big advantage is the decentralized one supports overlapping IP addresses. Also, because you have one endpoint per VPC and one security group per VPC, it also will allow you to have more granular endpoint policies and security group policies. Chargeback is way simple in this case, and then you can scale up to 40 gigs per bandwidth per available zone per account. In the centralized model, we have different benefits. The first one is lower IP consumption because you're only deploying the endpoint once. It also has some security group and endpoint challenges. The main challenge is, let's imagine this is your endpoint policy and you are allowing the different API 1, API 2, API 3, but then the more APIs that start to be behind that API gateway, for example, then you might end up just allowing everything and just like a wildcard. Also from the security group perspective, you might start with very specific security group rules But then the more security groups that you need to allow and you need to add to your security group, then you end up maybe just whitelisting everything. So you need to keep in mind that you will have a single endpoint policy and a single security group, and it might be a little bit too difficult to start allowing list each one of them, and you might end up just allowing everything. Also, in the centralized model, you are limited to 40 gigs per second across all accounts. So, just to let you a little bit of conclusions on this part is that decentralized approach is a great use case when you have high throughput applications, because you're going to manage a lot of security groups and a lot of endpoints policies. Then it's a good idea to have a DevOps culture in place, and it's also a great use case when you have simple VPC design. Decentralized is a great use case for serving multiple endpoints across many accounts. Also, scenarios when you have an existing transit gateway, then the integration might be simpler. And when you need to support multi-region and hybrid scenarios, then the centralized one is a great use case as well. So now let's move on into the scenarios. The first scenario is, let's assume I have an unicorns rental company that they have more than 100 accounts, and they send high volume of logs to Kinesis, and they need to be charged back. Each VPC or each account, each of those hundreds accounts need to be charged back. The architecture looks something like this. You have in here your Kinesis, where all the logs are going to be sent, and you have your 100 accounts. Of course, I didn't draw the 100 accounts, but the idea is that each account needs to send logs to this Kinesis. You might be thinking, well, I just can put a centralized approach, transit gateway, and then from each of the 100 accounts, go to the transit gateway through the Kinesis. But remember that this is high volume of logs. You might end up hitting the limit, the 40 gigs per second limit. Also, each gig that it traverses through the transit gateway will add to your cost. So, might not be the best case scenario for this. Maybe a decentralized approach where each endpoint lives in separate account is a better fit. But let's analyze this architecture and this use case from the three different perspectives. From the cost one, each account is consuming a single service. In this case, it's Kinesis. And they have 100 VPCs, so they might end up with 300 endpoints. Doing the maths, then the decentralized approach is more cost effective. From the management, they will be able to support overlapping IP addresses. They will have a large IP consumption. Each endpoint will consume one IP, but they will also have support for chargeback. Remember that they need to charge back each account. The service catalog on an automation is a must. They will be managing 300 endpoints, 300 security groups, and 300 endpoint policies. So they need to have some type of automation in order to manage this amount of security groups and policy endpoints. They will also have support for notifications. From the security perspective, they will have a consistent enforcement. They can have very granular security group and policy endpoints. But now, let's change only one thing to this case. And rather than only consuming Kinesis, now they also need to consume an extra 2 services. They still need to charge back, but now rather than a single service, they're going to consume 3 services. So from the cost perspective, the price changes now. The centralized one has a lower price, because now rather than 300 endpoints, they're deploying 900 endpoints. But remember that this is a high volume of logs to Kinesis. So there is a limitation on the endpoint in a centralized approach. Are they going to hit this limit? Well, something to keep in mind. So at this point, they need to put everything in a balance. If they go with the centralized type of approach, they might hit some limits. If they go with a decentralized type of approach, then they might end up paying more, right? So it's not one over the other. It's just having all the different factors in place to be able to make the right decision. Now let's move on and let's go into a different scenario. In this case, the company has 5 core microservices that are deployed in multiple regions, and they have 50 accounts. Each of those 50 accounts need to consume the 5 different microservices. And it's generally low traffic, and then services can be deployed in any regions, and they need an integration with on-prem. So the architecture looks like this. They have the centralized account, and from each centralized account, they are consuming the 5 microservices. I only draw 3, but let's assume they're 5. And the transit gateway is the one that is going to allow us to make the connection. All the consumers are going to be in different regions, and I'm going to use a transit gateway peering between regions in order to make this microservice available to consumers in different regions. Also, if I want to consume the services from on-prem, then using transit gateway and ending my VPN or my direct connect on the transit gateway, then it's possible. But now, remember that the centralized type of approach has a third consideration, and it's DNS. So from the DNS, they need to create a private hosted zone, share that private hosted zone with the consumers and with the shared service account, and also maybe create a resolver endpoint from on-prem, and then they will be able to set up this type of configuration. From the 3 different perspectives, the cost, they are consuming 5 services because there are 5 microservices. It means 50 VPCs, 3 available zones, still single account, so 15 endpoints. Price for the centralized is lower. From the management and security perspective, management, they have lower IP consumption, but they won't be able to support overlapping IP addresses. And most important, they will need to set up DNS, and they will need to maintain the private hosted zone and resolvers in a big scale. So that's something that they need to manage now. And if at some point they need to charge back, then they need to disaggregate the VPC flow logs. From the security perspective, they'll have a single security group and a single endpoint policy, so they need to have an allow list mechanism in order that every time that a new consumer wants to access to that microservice, then they need to be able to add it to the allow list, or they might end up with a too permissive security group. Okay, so now I want to leave you with some key takeaways. The first one is one size doesn't fit all. It is not like the centralized is a clear choice for some use cases and the decentralized is another use case. It's not. You can mix. It doesn't mean that you have to choose one over the other. You can mix the centralized and decentralized type of architectures per application, depending on your application. Now, let me just give you some basic guidelines that I've been speaking about. The first one, if you're going into a multi-region or an on-premise type of architecture, then a centralized, because of the transit gateway, makes a lot of sense. If you have low traffic and idle endpoints, a centralized makes sense as well, because you won't be paying for a lot of endpoints that are not being used. You only pay in a centralized account for those endpoints. But if you need more than 40 gigs per sec of bandwidth, then you definitely have to go with a decentralized one. However, if you need more than 40 gigs, please speak to your solution architect. We want to listen to your use case. Another consideration is if you need support for overlapping IP addresses or for chargeback, then the decentralized makes that easier for you. If you have high number of endpoints, centralized is more cost effective as well. And if you want fine-grained security and if you have a DevSecOps culture in place, then decentralized makes sense as well. As I say, these are some guidelines, but please work with your solution architect in order to choose one over the other. And remember, it's not just one over the other, both can live at the same time. I hope this has been informative. I want to thank you for watching this presentation, and thanks again. Bye-bye.